Hi friends, in this one I'm going to show you how to analyze a polynomial and make a graph of it. So we have here the following, f of x is equal to x to the fourth minus x squared. Okay, so first, for example, find the y-intercepts. That would be f of 0, so it's going to be 0 to the fourth minus 0 squared, which is 0. Find the roots, so you take x to the fourth minus x squared, you set that equal to 0. Factor an x squared out, so x to the fourth is like x squared times x squared minus x squared times 1 is equal to 0. So factor that out. X squared, then you have x squared minus 1 left over. X squared minus 1 is the difference of squares, so this becomes x squared, and then this becomes x minus 1, and then x plus 1, this whole thing is equal to 0 this way. Okay, so we have the y-intercept, we have the roots from here. So either x squared is 0, x minus 1 is 0, or x plus 1 is 0. So from this one, the only way this can be true is if x is equal to 0, like this. So because 0 squared is 0. The only way x minus 1 is 0 is when x is equal to 1. So just add 1. And the only way x plus 1 is 0 is when x is equal to negative 1, this way. Okay, so we have, let's see, the roots, and we have the y-intercept at 0. Also, let's look at the end behavior. So end behavior, remember, is determined by the first term, by the dominant term. So I'll call that the leading term. That's equal to x to the fourth here. The quick way to do this is just plug in like x equals positive 10, because that's pretty far to the right. So when you do that, you're going to have 10 to the fourth. Well, what kind of number is that? Well, it's a positive number, and it's, remember, it means 10 times 10 times 10 times 10, which is 100 times 10, and then times another 10, so it's 10,000. The point is it's a positive number. So on the right side, because x equals 10 is on the right side, the graph is going up. Plug in x equals negative 10. So it's going to be negative 10 within parentheses to the fourth. That's still positive 10,000. You can check it for yourself. The point is then the graph is going to go up this way. So we have a lot of important information. Let's gather most of this into a graph now. So I draw a graph like this and like this. Okay. Remember, this is x, this is y. Okay, mark the information. So mark the roots, for example. So 0 is a root. Okay, negative 1 is a root. And then positive 1 is a root. So x equals negative 1, x equals 0, x equals positive 1. We've got our roots. Good. Mark the end behavior. On both sides, the end behavior is up. So you're going to have this going on, and you're going to have this going on right here. Okay, so now we just have to understand what happens between negative 1 and 0 and between 0 and 1. Well, what you can do is just plug in negative 0.5, and then here plug in positive 0.5, like that. Just plug these values into the function, see what the outputs are that you get. So if you do that, we're going to have f of negative 0.5. So that's the same as, let's see, negative 0.5 raised to the fourth minus 0.5 raised to the second. And I've done this calculation before, but punch it into your calculator. You should get roughly like negative 0.19. So let me erase this a little bit. Let me put this here. So negative 0.5 goes here. Let me erase these so they fit better. And this is x equals negative 1. So this is, remember, this is a value of y, okay? So negative 0.5 goes in, negative 0.19 comes out. Say that's about here, like this. Okay, same thing over here. Let me erase this, put this here. So this is 0.5 in this position right here. So calculate f of 0.5. It's the same thing really, because this exponent here is even, and this exponent is even. 1 is 4, 1 is 2. So you're going to get 0.5 to the fourth minus 0.5 to the second. You go through this calculation and you find that it's also negative 0.19. Negative 0.19. So that gives you a point about here, okay? And this is x equals 0, so this is x equals 0 right here. Let me make that smaller. That's x equals 0. So then you connect. You see, like this, it goes with the root, it goes with this. Now, it goes here and it doesn't wander off. For example, like back across the x-axis. Let me just explain why. So go back over here for a second. You see, this is x squared, right? So there's a 2 up here, and this is equal to 0. Therefore, x equals 0, this is a root of even multiplicity. So it bounces, okay? That means when it hits this, it's going to bounce off, and it's going to hit that point, and it's going to go through here, and it's going to pick up and then continue on this side, this way. Each of these roots, the negative one and the positive one, each of those has a multiplicity of 1. So go back here for a second, okay? Look at this. You see, this is like x to the x minus 1 to the first, x plus 1 to the first. So each of these roots has a multiplicity of 1. Therefore, the graph crosses those roots. And this is a pretty good way of sketching a polynomial of this kind. So again, y-intercept, roots, think about multiplicity a little bit, even bounces, odd usually crosses, and also the end behavior. If you can capture that, then you can sketch the graph pretty well. But that is it. So I hope it's been helpful. Please leave a like, please subscribe. Thanks so much for watching. I will see you in the next one.